to DC or not DC? That's the question we're going to answer today. Hi, welcome back to the channel, and in this episode we're going to cover the differences between DC power and DCC power and try to help you understand them so that you can make an informed decision. And we'll do that right now. So what is DC power anyway? Well, if you think about it, we use DC power all the time. If you have a flashlight or a portable radio or something like that, you're using batteries. Batteries have a negative and a positive end that you always screw up the first time you put them in. But anyway, the power always flows from positive to the negative, regardless of whether it goes to a flashlight bulb or a motor or whatever. And model railroading has used that concept for almost 100 years. And then a new kid on the block came along called DCC. So the differences are you've got power that flows through from the positive to one rail, goes through the motor of the locomotive and out the negative side and back to the power pack. And like I said, this is the way just about every train system from Lionel down to Z scale and G scale as well operates. And like I said, that's been almost 100 years. So how does it work? Well, we've got this typical DC power pack here. You've got your direction switch, which, okay, it's just, does the train move to the left or the right? This is a combined on-off switch and throttle. So you would click it, there's a little light that would come on here. Try to get that better in the camera. And you would turn this to increase or decrease the speed. And the connections to the track are very simple. Up here, you've got your positive and negative leads that go to the track. And then you've got two other leads here. These are for accessories, which you can buy in, I don't know, the old school thing was like you would dump logs out of a car or a little guy would pop out of the shack or something like that. And this, of course, is the input from a wall power supply, like you would have an adapter. Okay, that's how these operate. Some come with their own power built in, and you just plug into the wall, and everything is self-contained. But this particular model works the other way. So that's DC power in a nutshell. And like I said, we've had that for almost 100 years. And that's all we've had. But then a new kid came along, and he's called DCC. Now this is an example, not the only kid on the block. This is the power cab. This is a beginner, you want to call starter, DCC controller. This is self-contained. There's a fascia plate, which I'm using somewhere else right now. But this would have a fascia plate that you would mount to the front of the layout, and then this simply plugs in with this little phone jack onto the side. And once you apply power, like back here, you would plug in a wall adapter. You can then, this whole thing will light up and you will have power to your track. Now, funny thing is, it's still DC power. We haven't changed how the layout is powered. We're changing how the power is delivered. That's the key. So what is DCC? DCC stands for Digital Command and Control. which in a nutshell, it explains itself what we're doing. So I send commands out here and I can control the train. Now, if I'm using a strictly DC power pack, I have control of one train in one direction, and that is it. Regardless of how many trains I put on the track, they're all going to go in the same direction. Give you an example. So we have this set to go to the left. Let's assume that the wiring matches the direction switch. So if we flick it to the left, the train is going to go clockwise. If we flick it to the right, the train is going to go counterclockwise. Regardless of which direction the locomotive is pointing, it's going to follow the current. So if the current says, well, you're going to go to the right, you're going to go to the right, regardless of which way you're pointing. And regardless of how many trains are on the track that are DC. So that is how it would be controlled. Now, is it simple to operate and simple to use? Absolutely. You have two wires, you're connected, you're done. But the problem becomes controlling more than one train at a time. Or if you have a larger layout, let's say, and you said, I want to use DC, okay, it's cheaper than going DCC, which we'll see, but you run into the issue of I have to isolate those places. Like, let's say you have a main line and you have a train running on the main line. Well, you have a siding or a yard or something else where you have another train, or locomotive rather. That locomotive is going to want to go unless you isolate it with an on-off switch. So then wiring comes into play. And if you're not up on wiring, then you need to get a book. And you need to learn, okay, I have to do this to isolate this. I have to make a big control panel over here so that I can control what happens over here or what happens over there. So there's a give and take. It's cheap to buy, but more complicated to operate. So then we get into the DCC part, and the DCC, well, it's different. And we're going to see that here, because I'm going to give you an example of locomotives. So you have four categories of locomotives. You have a DC only locomotive. Now, those are prevalent in almost every scale. A lot more I've seen in N scale, where they're strict, that you can buy them, modern releases that are strictly DC. And if you look, when you go shopping for these, you're going to see four categories. Regardless if you shop online, you shop in the store, you go to a train show, whatever, you're going to find ones that are marked DC only, which you can't run on a DCC track ever unless you go through and you butcher the inside of it and have a knowledge of how to install DCC. You have ones that are DCC Ready. Now that's a big category, and there's a lot out there that they offer in both categories, like DC and DCC Ready. So if you buy something, you find something you like, you could probably find it in DCC Ready. And the advantage of that is, let's say you're starting out and you know you're going to go to DCC eventually, but you can only afford to do DC right now. Well, that allows you to buy a train, a locomotive, run it immediately, and enjoy it. But later on when you're ready for DCC, and we'll show you in just a little bit how that all works, you can easily convert it to DCC. So, it kind of helps getting started. That's a cheap way in where you can enjoy both at the same time. Then you get ones, a category that I've seen a lot in N scale, not so much in HO, but there are some, is the one that says DCC equipped. Now, DCC equipped means I have a DCC uh, decoder. That if I say chip, excuse me, I mean decoder. But that's basically what it is. You have a little decoder that's inside it, and what it will do is it will operate on the DCC layout, but its controls are limited. Like some may just be controls a light, controls the speed, obviously, and the direction, but doesn't do anything else. Now, there's a last category, and this is usually the most expensive of all four, and that's the DCC and sound. You'll say a little plus in sound, or it'll say and sound. These are the cream of the crop, if you want to think of it that way. Not only do you have control of the speed, the direction, the lights, you now have control over what sound effects it makes. And that can be a big factor, in how much realism you get, because just going around a layout, eventually you're going to, even a good size one like this, if it's just DC or DCC with no sound, it's kind of boring after a while. But when you get the sound effects added in, it takes it to a whole nother level. So let's stop here. We'll take a look at what a DCC Ready locomotive looks like, and we'll point out how it would work and what you would need to do to get it to DCC. Okay, so let's take a look at what a DCC Ready locomotive looks like. So we have here a typical DCC Ready locomotive. What we have here is what I nickname the motherboard, computer background, but a lot of DC only locomotives will also have this. They just, what you will differentiate them is going to be right here with this, I like to call it a computer chip sometimes, but really what it is they call it a dummy decoder. So your DCC decoder would not be included with this, obviously, if it's DCC Ready. Now, if it says DCC equipped, this won't be here. There will be a DCC decoder of some sort, whether it's one that has sound or does not. You'd have to see what the box says. So we have this motherboard here, and all your functions that the locomotive is capable of are wired to this motherboard. So, for an example, down here there are two connections, and they go to the headlight. Okay, there are two other connections, one right here and one right here. These are the leads that come to the motherboard from the track, from the wheels to from the track, and then it feeds into the motherboard. Now up here on top, you have two leads. These are for the motor down here, and they're also wired directly up to the decoder. So under here you have 21 pins. Now most of your modern DCC decoders are 21 pin. Now they do make older models, I don't know, 10, 15 years ago, that had 8 pins, some had 9 pins. You'd have to check and see what kind you have. They still make those, although they're kind of limited. And with ones like those, they're not going to have very many functions. If you're 8 pin, chances are it's not going to have sound, or it's going to be really tinny sound. And it's just not going to be very good. I mean, it's an older generation, let's put it that way. The 21 pin is the latest models that they make. And even an inexpensive one, like I have a model similar to this. Actually, it's the same exact one. It's just I took this out already, replaced it with an inexpensive DCC decoder, which ran me about 60 bucks, give or $60 to $70, I believe it was. Replaced that, and in here in this housing is for a speaker. You notice here on top here, there's two little solder points. Those would be for your speaker connections. So you would wire the left and the right, you know, the black and red, to go, or whatever colors you want, to go into a 28 millimeter round speaker for this one. This particular model is already got the housing for it. There's no speaker inside. There's just this housing that's ready to accept one of those. So you would wire one from here to this point, and now it becomes a DCC with sound capability. So that's all you have to do then. Is if you didn't even want this, all you'd have to do is replace this dummy DCC, pull it off carefully, like you would take. Let me see if I find here. Just like take a little screwdriver, you know, a little flathead like this, and you would get underneath and just pry it up carefully on both sides because you don't want to bend the pins. And then you would check the orientation on your decoder. Now most decoders would run this way just because that's how the standard is for the pins. There's 11 on top and 10 on the bottom. I believe this corner is the one that's missing. I'm not sure. I don't think it's this one. I'm pretty sure it was this corner. And you would, like I said, pull it off and then carefully push the other one in until it clicked, and that's all there is to it. You know, I mean, there's replacing and making something DCC as far as just to run on DCC and no sound is very simple. Especially, like I say, if you buy one that's DCC ready, you're good to go. It's just a matter of pull this off, put a new one on, put the shell back on it, and you're done. As far as that installation goes. Now, programming it, that's another thing. Most of your programming is going to be done through your controller. Now, this particular one, you have to use something called the CVs. They're the control variables. You would go down here into the programming mode and go through a couple of screens until you get to the part where it says CVs, and then you would have to look on your list from the manufacturer. I believe I have one right here. Yes. Okay. So this is the decoder that I installed on the one that's similar to this, and it would tell you, like up here, if you want to change some of the CVs, where your reset is, and reset's usually on CV number 8, and you give it a value of 8. This tells you your bell selections and how to set your master volumes and things of that nature. Doing that much isn't bad, but when you want to get into doing things like changing, I don't know, the speed and things like that, it gets a little more intricate, and you need to actually do, well, for me, do something a little bit more involved. I prefer to hook mine up to the computer and use something called JMRI. JMRI is a free program that you can download into your computer, and all you need in the case of this one, if I was using this NCE power cab, I would need to obtain an NCE USB interface. Now what this does is it helps the power cab talk to your computer. This would be mounted in behind the fascia. Your power cab is on the left side. You would take this plug it in on the right, and then obviously goes through here. And then this end with the USB would plug into your computer. Now you could use a laptop or you could use a tower, doesn't matter. I personally have a laptop. It's much easier for me. I can move it from the office to in here if I need to use it for anything. But if you have a dedicated tower and displayed somewhere, then more power to you if that's the way you want to go. But what's nice about that is you're not just looking at numbers. When you have the JMRI, you can actually see names of things, and it will list exactly what you have. It will tell you, like on here you have different functions. Like when you have this lit up and you have a locomotive, you would say, okay, function 0 is for my headlight. Well, this one already has those normal ones that you use all the time built into it. But on any other one, you would have to hit like the 0, okay? So it'll say, okay, so function 8, let's say, is your startup on there. So it would show you on a list what each function is. And then if you wanted to, you could customize that DCC simply by going, okay, well, I'm going to change function 5 to a crossing horn, to signal for a crossing. So that's what's neat about JMRI, and it works very well. I mean, once you get it downloaded and it plays nice with your system, you're good to go. So I believe that's all we have as far as DCC for today. What I'd like to do is, in our future videos, we're going to cover things like doing scenery, track laying, that's an important thing. Also doing trees, there's as many ways to make a tree as there are trees. Another thing I'd like to do is go to different layouts, show you what other people have done, maybe see they have a different approach on how they built their railroad. We might even be able to get to actual prototypes and see some things, put on the channel, actual railroads in operation. So that's going to do it for today. Be sure to like, share, subscribe, and check out the next video, and I'll see you in the next one. Take care.